Hello everyone, today I'll be solving the 9701 Chemistry AS level, paper 12, May June 24. I'll be continuing from where I last left off at question 15. So now I'll start from question 16, then finish it to question 40. Question 16 asks, which statement is correct? Aluminium chloride has a joint ionic lattice of Al3 plus and Cl minus? No. In general, we know that AlCl3 exists as a simple covalent structure. Sodium chloride dissolves in water, forming hydrogen bonds, hydrogen chloride and sodium hydroxide. No, it only dissolves, forming Na plus and Cl minus. Is the same with the MgCl. Strong covalent bonds in silicon chloride prevent it from reacting with water. SiCl4 does react with water in a hydrolysis reaction. Forms SiO2 and water. When phosphorus pentachloride is added to water, the resulting solution conducts electricity. So let's look at the reaction of phosphorus pentachloride and water. It forms H3PO4 phosphoric acid plus HCl. This HCl dissociates, forming H plus and Cl minus. So these ions conduct electricity. So D is the answer. 17. A mixture of calcium carbonate, calcium nitrate, strontium carbonate, and strontium nitrate is thermally decomposed. The decomposition reaction of each substance goes to completion. Each substance is anhydrous. How many different products are formed? So let's look at calcium carbonate and calcium nitrate. So both will have a common product of CaO. So this is one, and then the carbonate will form CO2. The nitrate will form NO2 and oxygen. So these are 4 reactions for the calcium. Now let's look at the strontium. It forms SRO, strontium oxide, and then these are the same here also, so it's not unique. So we don't count them again. We only count 1, 2, 3, 4, and 5. So there are 5 products. 18. W is a solid that reacts with water to produce an alkaline solution. The addition of 2 drops of dilute H2SO4 to this alkaline solution produces a white precipitate. What could be the identity of solid W? Okay, so the alkaline solution, so it can't be phosphorus oxide because it will form phosphoric acid, which is very acidic. So these are the possible answers for now. Let's see. So on addition of dilute H2SO4, it forms a white precipitate. So that means the sulfate is insoluble, and we know that group 2, the solubility of sulfates, it decreases down the group, so the elements at the top are more soluble. So magnesium has a soluble sulfate, so magnesium is not the answer. It's going to be barium oxide. Chlorine gas is reacted with cold aqueous sodium hydroxide. Which statement is correct for this reaction? So let's look at the reaction real quick. Cl2 plus NaOH cold makes NaCl plus NaClO, sodium chlorate 1, and water. So chlorine here is 0 because it's an element form, and then here it's -1 and here it's +1. So it's both oxidized and reduced. Yes, A is the answer. Let's look at the other options. Neither. No, it is. Chlorine is oxidized but not reduced. No, it is both. Reduced but not oxidized. Okay, so A is the answer for sure. Sodium is added to water to form solution Y. The pH of solution Y is measured. When powdered substance X is added to solution Y, the pH falls. So it becomes more acidic when X is added. So X has to be something that is acidic. So K2O is wrong. So B and D are not possible answers. It's either A or C. Sodium is added to water to form solution Y. The pH is 13, or like a very basic pH. When the substance X is added, solution Y, the pH falls. So which two could be substance X? So it has to be something acidic. NaCl is neutral solution, so C is not the answer. MgCl has a pH of 6.5, which is slightly acidic. It still counts, so A is the answer. 21. The table shows the statements about some of the properties of halogens and their compounds and explanations for these properties. Which row shows the correct statement about the property and a correct explanation for the statement? Statement. Iodine is solid at room temperature. True. Explanation. The II bond strength is high. When talking about melting and boiling points, the the bonds within the molecules are not really the factor, so A is not the answer. B. The decomposition of hydrogen iodide is more endothermic than the decomposition of hydrogen chloride. Okay, so more endothermic means it needs more heat, because you know the definition of endothermic means takes in heat. So endothermic means needs more heat, and we know that down the group 7, the thermal stability decreases because the bond length increases. So let's look at why. HI, why is it that long, and why is HCl only this short? So if we look at the iodine atom itself, it's way larger than the Cl atom. So there is more shielding, or there is a greater distance between the bond pair and the nucleus of the iodine. So there is a weaker attraction between the nucleus and the bond pair, so it can be broken easily. So it's not more endothermic, it's less endothermic because it requires less heat. When chlorine is bubbled through into aqueous potassium iodide, a purple solution is seen. So Ki, and then you add Cl2. Cl2 is a strong oxidizing agent, and this is a strong reducing agent. So the iodine will reduce the Cl2 into Cl minus, and the chlorine will oxidize the I minus into I2. So the iodine in solution is actually not purple, it's brown. So you have to know the colors of iodine in solution. It's brown in solution, purple in vapor, and grayish black in solids. So C is not the answer. D. When concentrated sulfuric acid is added to solid potassium iodide, a purple vapor is seen. Yes, because iodine is a very strong reducing agent, so it's easily oxidized by the sulfuric acid, which acts as an oxidizing agent here. So it oxidized the iodide into iodine. Let's look at the explanation. Iodide ions are being oxidized to iodine by the sulfuric acid. That's true. So D is the answer. Which statement describes the property of an ammonium ion? An aqueous ammonium ion is a weak bronzed Lowry base. So let's look at NH4 plus. NH4 plus usually donates this extra hydrogen, the proton, so it acts as a proton donor, which is a bronzed Lowry acid, not base. A is not the answer. B. Aqueous ammonium sulfate reacts with dilute hydrochloric acid to make ammonia gas. So ammonium sulfate or ammonium salts in general, they do not react with acids to make ammonia gas. So this is not true. It's only bases that do. Bases react with ammonium salts to form ammonia gas. An ammonium ion has a pyramidal shape with a NH bond of angle of 107 degrees. So let's look at the ammonium ion. It's basically a tetrahedral since it has no lone pairs. So it's not a pyramidal shape, it's a tetrahedral. The 4 NH covalent bonds in ammonium ion are identical to each other. So although yes it has one dative covalent bond, they are all identical though they share 2 electrons. So even if you're not sure about D, all the others are like completely wrong. So you can either choose your answer by proving or disproving the others. By proving the answer you're thinking of, or by disproving the other options, which is basically elimination. Catalytic converters are fitted into the exhaust systems of many cars. Causes acid, so gas X causes acid rain if it's released into air removed from car exhausts. Okay. Carbon dioxide is not actually removed, it's not formed either, but yeah, it's formed in catalytic converters. So if you look at the reaction, or the overall reaction, CO2 is a way less harmful gas than CO, so it's formed. So you form CO2 rather than CO. So carbon dioxide is not removed, so it doesn't fit in the second point. So carbon monoxide, it does fit the second bullet point, but doesn't fit the first bullet point. It doesn't cause acid rain. Only NO and SO2 cause acid rain. Carbon monoxide, no. Hydrocarbon vapor, it doesn't cause acid rain. but it is removed from car exhaust fumes by catalytic converter, yes, but doesn't fit the first bullet point. So C is not the answer, D is the answer. Nitrogen dioxide, it fits both. Actually, there's another reaction, yeah, if you're asking, there's another reaction of CO plus NO2. But this is like mainly used, but this is also important. Alright. In the general formula of which class of compound is the ratio of hydrogen atoms to carbon atoms the highest? So let's look at the general formulas. Alcohols are basically like alkenes, but then they have the extra oxygen, CnH2n plus 2O. Aldehydes, CnH2n like alkenes, but have an oxygen to them. Carboxylic acid, CnH2nO2. Halogen alkanes, CnH2n plus 1x. Okay, so if you don't know how to find the general, or like don't remember or didn't memorize them like I do, I don't memorize them. In the exam I just draw a random structure. For example, let's draw a carboxylic acid. Find the molecular formula. 1, 2, 3, 4, O2. Then find the, like, simplify it basically. CnH2n O2. But here's the catch. In carboxylic acid, you don't really simplify the 2 for the oxygen, since it's 2 in every carboxylic acid, unless it's a like diacid. But yeah, in the general formula it's just O2. Okay, so let's look at the ratios now. So this is has n to 2n plus 2. This has n to 2n. This has n to 2n. This has n to 2n plus 1. So the highest ratio is this one. There is way more hydrogen atoms than each. This was close, but it has one less hydrogen than alcohols. So alcohols is the answer. Which statement is correct? Adding sodium oxide to water gives a lower pH solution than adding silicon oxide to water. So a lower pH means more acidic, which is wrong because sodium oxide is very basic. The oxidation state of sodium in its chloride is higher than the oxidation state of silicon in its chloride. So NaCl, SiCl4, here it's plus 1, here it's plus 4. So B is wrong. The atomic radius of sodium is larger than that of silicon. Okay, so let's see the atomic radii. So it decreases down across the period because the increase in nuclear charge and the shielding is fairly similar, and so you have an increased nuclear attraction on the outer electrons, so it pulls them closer, so there is a decreased atomic radius. So yeah, sodium is larger than that silicon. Melting point of chloride of sodium is lower than the chloride of silicon. SiCl4 is actually a simple covalent, only SiO2 is the giant covalent. So SiCl4 is simple, so it has a very low melting point, but then NaCl is ionic, so it has a very high melting point. So D is wrong, C is the answer. 26. Z is a gaseous hydrocarbon which has a density of 3.50 multiplied 10 to the power of -3 grams centimeter cube under room conditions. Okay. Z reacts with an excess of hot concentrated acidified KMnO4. Only one type of carboxylic acid is formed. So let's clear the easier part. Only one type of carboxylic acid. So let's see butene. So it's symmetrical. So if you break this, each one has one H. And as you know, CH2 and C, this one forms a carboxylic acid, this one forms CO2 and H2O, this one forms a ketone. These have to be memorized. So these two will form ethanoic acid, so A is valid. 2,3 dimethyl. So if it's symmetrical and each have the same number of hydrogens, then yeah, they will form the same type of carboxylic acid. 2,3 dimethyl butene. 2,3. Now these will form ketones, so B is wrong. Hex 2E. So this is not symmetrical. This will form butanoic acid. This is ethanoic acid. So C is not valid. Hex 3ene symmetrical. So yes, valid. Now let's clear the second point. This needs some space. So it said the density is 3.50 multiplied to the power of negative 3 gram per centimeter cube. So we know one way to reach gram per centimeter cube, which is multiplying mole per centimeter cube by the MR. This is from the O-level days, because you have mole over centimeter cube, and then if you multiply by the MR, so multiplying the mole by the MR, so you get gram, the mass. Because if you look at the triangle here, N, M, MR, so mass is N multiplied by the MR, so here this gives you the mass, so gram. Okay, so this is just fluff. Alright, so how do you get mole per centimeter cube in the first place? So it's at the room conditions. So every 1 mole of gas takes 24 decimeter cube. So that means if you convert this into 1 mole, it takes 24,000 centimeter cube, because from decimeter cube to centimeter cube you multiply by 1000. So that means the concentration is basically 1 over 24,000 centimeter cube, and then if you multiply by the MR of either of these, you get this. So let's check. The MR of butene is 56. I'm gonna spare you the work. And hex 3ene is, let's calculate. So hex 3ene is C6H12. So that's 12 multiplied by 6 plus 12. 84. So if you multiply, okay, let me just erase this real quick. So we said that the concentration is 1 over 24,000 mole per centimeter cube. Okay, so if you multiply the MR 56 by this, let's see what you get. 56 multiplied by 1 over 24,000, you get 2.333 multiplied to the power of negative 3, which is, no, it's not the same as this. Let's try 84 now. If you multiply by 84, you get 3.5 multiplied to the power of negative 3, which matches. So D is the answer. 27. Compound X can be oxidized to compound Y. Compound Y gives a yellow precipitate with alkaline I2 or iodine, aqueous iodine. Okay, so compound X can be oxidized, which means it's not a ketone, it's not a carboxylic acid, or it's not a tertiary alcohol. Compound Y has a methyl attached to a carbonyl or alcohol with CHOH. So let's see. So it's all alcohols, so we get the ketone stuff out of here. So let's look at the structures. Butane 1-ol, and then you have butane 2-ol, methyl propane 1-ol, methyl propane 2-ol. So first thing, this is tertiary, cancel this because it cannot be oxidized. And then compound Y, which means after this is oxidized, either of these three is oxidized, it gives something that can give a positive iodoform test. So let's look. If this is oxidized, it will give an aldehyde, but it doesn't have a methyl attached to it, so A is not the answer. Let's look at B. So this is valid. It will give a positive iodoform test. Let's look at C now. oxidized to aldehyde. The CH3 isn't directly attached to this carbon, so it is not valid. And then C is cancelled, B is the answer. 28. Aqueous NaOH reacts with 1 bromopropane to give propan 1-O. What should be included in the diagram of the first step? Okay, 1 bromopropane is this. So it's a primary halogenoalkane. So it proceeds by SN2. So everything happens in the first step. Everything is in the first step anyway. So if you have a HH, use the arrow and then the dipoles. Then you have the OH already attacking the carbon, all in the first step, because it happens in one step. If you look at the energy profile diagram, it's only one step. This is the SN2 mechanism. Because it has space, first of all, there is no static hindrance, and since it can't really form a stable intermediate, so it has to proceed through the SN2. So a curly arrow from a lone pair of the OH minus to the C partial positive of the, okay, so this is valid, yes. This is what they mean, the arrow from the OH minus to the C partial positive. Okay, a curly arrow from the C partial positive atom 1 bromopropane to the OH minus, no, it's always from the electrons. The arrow goes from the electrons to the positive part. Curly arrow from the C Br bond to the C, no, it's the Br. The homolytic fission, no, it's hydrolytic because it forms ions. The Br comes as the ion with 2 electrons. It takes both of the electrons in the bond. In which reaction is the organic compound oxidized? So Tollens reagent is actually ammoniacal silver nitrate, which is a mild oxidizing agent. It oxidizes the aldehyde, and the Ag plus is reduced to make AgS, which is a silver mirror that forms. So A is valid. B, no, AlH4 is actually a very strong reducing agent, so it's the opposite. Concentrated H3PO4. So when you break alcohols, or when you remove like H2O from alcohols and you dehydrate them, it's not really an oxidation or a reduction. It's like both are happening, so it's an overall balanced. We don't really call it oxidation or reduction. CH3COO C2H5 plus dilute H2SO4. So you just this is the hydrolysis of the ester, and it's not oxidation. 1 mole of each of the following 4 compounds reacted separately with an excess of sodium and excess of sodium carbonate. Which compound produces the same volume of gas with each of the 2 reagents? So OH, it will both react with the excess sodium but not with the sodium carbonate. So A is not the answer because it has to react with both and at the same amount. So this has 1 carboxylic and 1 OH. Both will react with the sodium, but only the carboxylic will react with the carbonate. So no, because it will produce less hydrogen gas with this. C has an aldehyde and an OH. The aldehyde won't react with the OH will react with the sodium. So no. Now this has 2 carboxylic groups. They will both react with the sodium and they will both react with the sodium carbonate. So D is the answer. Which reaction will distinguish between propan 1-ol and propan 2-ol? Propan 1-ol and propan 2-ol. So if you look at the structures, iodoform test would actually distinguish between these two, but it's not here, so throw that out. Let's see. Warming with acidified, no, they will both get oxidized because none of them is a tertiary alcohol. Dehydration followed by reaction with Br2. If you dehydrate this, it will form this, and if you dehydrate, it will form the same alkene. So they will both react with Br2 the same. Mild oxidation followed by reaction with Felling's reagent, yes, because when you oxidize this, it forms an aldehyde, but if you oxidize this, it forms a ketone, and only aldehydes get oxidized. So they react with the only aldehydes react with Fehling and to produce a red PPT. So D is the answer. Compound T has the skeletal formula shown. Which structure is structural isomer of compound T? Let's do the easiest thing when you're trying to find isomers. Count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's eliminate anything that doesn't have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Valid. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the answer is between A and D. So now let's look at the parent chains, if they are the same, and the branching. A. So the longest chain I see is this one. This is the longest chain. You can see it's the same. It has these two like ends, and then it goes for 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the same parent chain. Now let's look at the branching. So it has a branch here and here, and it has the same also on this. So it's not really a structural isomer, it's just the same compound. Let's look at D. The parent chain is 1, 2, 3, 4, 5, 6, 7. So it has maybe this parent chain. And then the branching on it, there is one branch here, and then there is another ethyl here. But here there are only methyls, there is no ethyl. So this has a different branching, so it does have a different structure formula. But this, it has all ethyl just like this, just like compound T basically. So it's the same compound, but D is a structural isomer indeed. Diagram shows simplified structure of coenzyme Q10. Which row describes the structure of coenzyme Q10 correctly? The enzyme is can't really find any aldehyde groups here, so it's an aldehyde. Ketone is more like it. There are two ketone groups here, so ketone. Number of pi bonds in one molecule. So we have here, this is 1, this is 2 pi bonds, and then 3, 4, and then here is the fifth one, but it's an N. So it's 4 plus however many N is. So N plus 4, D. The molecule of limonene, C10H16, contains a 6-membered ring. This is the only cyclic component in its structure. Which volume of hydrogen at room conditions is required to react completely with C double bond with CC double bonds in one molecule of limonene? Okay, so let's try to construct a imaginary or like a fake structure of limonene, because we don't know the actual structure. You're not supposed to memorize it. 6-membered ring, so a hexagonal ring. Okay, and then it has 4 more carbons, so let's make 4 methyl groups. So now we have 10 carbons. Let's look at the hydrogens. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 hydrogens, and we need to remove 4 of these hydrogens by adding double bonds basically. So we have to make it to C10H16. If we add a double bond here, this removes 1, 2. So each double bond removes 2 hydrogens. So if we add another double bond, now we remove the other 2 H, so it became C10H16. So now I have a kind of like a fake or a imaginary structure of limonene. So it has two double bonds, and each double bond reacts with 1 mole of H2. If you look at like ethene, if you add H2, one H goes here, one H goes there. So 1 mole of H2 reacts with one double bond. So we have two double bonds, so we have 2 moles of H2. And at room conditions, 1 mole of gas takes 24 decimeter cube. So multiply 24 by 2, 48. Answer is C. 1 bromopropane reacts with hot ethanolic NaOH. So this is an elimination reaction. What's the molecular formula of the product? 1 bromopropane. So this is an elimination to form an alkene. C3H6. A is the answer. These are all weird answers. Doesn't form anything with oxygen and doesn't form an alkene. It forms an alkene. Sample of pent-2-ene-4-ol contains all the possible stereoisomers of this compound. How many stereoisomers are there in the sample? Pent 2-ene 4-ol. 1, 2, 3, 4-ol. Okay. Alright, so stereoisomers. Stereoisomers is basically the geometrical isomers multiplied by the optical isomers. So the geometrical, let's count. For each of them, you use the formula 2 to the power of n. 2 to the power of n. N is basically the number of double bonds that can show cis strands or the number of chiral carbons. Here you have one double bond that can show, so 2 to the power of 1 is 2, and here you have this as a chiral carbon, so that's 2 to the power of 1 again. That's 2 multiplied by 2, answer is 4. Which pair of reagents react to form a product with a chiral carbon atom? So this, you add H here and a bromine here, but then it will have 2 CH3s on both sides, so let's draw it for better clarity. If you add HBr, the H goes here, and then the bromine goes here. It has 2 CH3s, so it's not really a chiral carbon. This already you can tell it's not gonna be a chiral carbon because it has 2 CH3s, so that's out of the picture. C, let's look at C. CH3, CH2, CHO, then HCN becomes a hydroxynitrile. So this has OH, HCN, and C2H5. It's a chiral carbon, so C is valid. Let's look at D. So it's an ester. Esters don't have chiral carbons unless there is a branching, but there is no branching here, so no. C is the answer. Diagram shows structure of two esters, X and Y, that are formed in the ripening apples. Which carboxylic acids are formed when these esters are hydrolyzed by H2SO4? So you break it after the double bond O. So you have this as here, and this here, also this. Okay, so let's look at it. Ester X, the carboxylic acid is going to be ethanoic acid, so it's A or B. C and D are wrong. Ester Y, the carboxylic acid is going to be CH3, CH2, CH3 branched, so B is correct. A doesn't have the branch, it's missing the branch, so A is wrong, B is the answer. 39. Addition polymer is made from monomer Z. What is the structure of the polymer made from this monomer? So only the carbons that have a double bond are involved in addition polymerization, so anything that has like this is wrong. The O is not involved, only the carbons that have double bond. This carbon doesn't have a double bond, so it shouldn't be forming the continuation bond. A is wrong, D is the answer. Very simple addition polymerization question. Okay, so now we're in the IR spectroscopy. What is the identity of compound X? Here's okay. Compound X reacts with acidified K2Cr2O7 to form compound Y. So it's oxidized and forms compound Y. Compound Y is this. Okay, so let's look at the peaks. So the most prominent peak is this very broad peak. So it's an OH, and it's at 3000. So it's most definitely a carboxyl. So compound X forms a carboxyl. Let's look at other peaks. So this peak is at 1600, 1700, something about 1700. So it has a C double bond O. So this is just confirming the carboxyl suspicion. Anything before 1500 is really useless. It's the fingerprint region. Okay, so it forms a carboxylic acid. Propanoic acid will want to get oxidized. Propanone ketones do not get oxidized. Propan 2-ol, this will form a ketone. This will form the carboxylic acid, propan 1-ol. A is the answer. Thank you guys for watching. I hope this helped. Have a great day.